Hello, Geometry. Today's video lesson is on classifying triangles. Hopefully this is just a review. It should be skills you already have, but if not, welcome to classifying triangles. So a triangle is a polygon with three sides. We name it by using a triangle symbol and then the 3 points on our triangle. In any order, so I'm going to use A, C, B. But it could have been A, B, C, or any variation of those points. The vertices are just our points on our triangle, so A, B, C. Our sides are just segments, so I have segment AB, BC, and AC. And then our angles are just our vertices, so angle C, angle B, angle A. A, B, angle C. Now the side opposite angle A, we'll find angle A. Now go through your triangle and we hit side BC. Now angle opposite side AB, here's AB, go through my triangle and I hit angle C. So why are triangles so important? Well, here's just a slide to show you. They are the strongest figure that we have. They are stronger than rectangles. That's why we see them all over in architecture. They're just super strong. I will show you a demo next time we meet in class, but obviously since you can't see me, it's kind of hard to do so right now. Classifying triangles, we can do it in two ways. The first way is by their angle measures. So, start there. An equal angular triangle where all three angles are equal. Equal angular are equal. So, we know that there's 180 degrees in a triangle. I have three angles, so if they're all equal, they must all be 60 degrees. Okay, an acute triangle is where all angles are acute. A right triangle is where there is one right angle. Remember, we denote that with a little box in the corner. And an obtuse triangle is where there is one obtuse angle in your triangle. So right there, for example. The next way we can classify triangles is by their sides. The first one is equilateral, where all three sides are equal. And remember, when you have equal segments, we put little tick marks on them. An isosceles is where at least two sides are equal. Bing, bing, right there. And then scaling, obviously, where all three sides are different. None of them are the same. Classify the triangle by its sides and angle measures. So two answers. Let's start with the sides. I see that all three sides have the same tick mark, so that must mean it's equilateral. And then I notice that all angle measures are 60, so it's equiangular. So I'm hoping you're realizing that maybe there is a relationship amongst the sides and the angle measures, and there is. So if I have three equal angles, I'm going to have three equal sides. If I have two equal angles, I'm going to have two congruent sides. Now, obviously, if I have three random angle measures, I'm going to have three random side measures. Like in this example here, 4, 5, and 2.3 centimeters is going to make it a scalene triangle. And I notice that I have three different angle measures, and one happens to be obtuse, so therefore it is an obtuse triangle. Now we're going to practice sketching some of these on our own. Obviously, we've seen my sketch so far this year. I'm not artistic, so that's why we label things so we know what they're supposed to be. You can't always tell by just looking, so that's why we label. All right, so triangle KLM, for the measured angle K is 90 degrees. So we know for sure we're dealing with a right triangle, where K is my right angle. I have L and M. Now let's see what else it tells us. Where KL is 2.5 centimeters, and okay, and this 3 centimeters. So I know I have a right triangle, and I have the classified sides. Well, I know in a right triangle, my hypotenuse is always the longest length, so then I'm going to have 3 different sides, meaning it is scalene. Triangle XYZ, where the measured angle X is 60, and then it says all 3 sides are 3 centimeters. So I know I'm dealing with an equilateral triangle, 3 centimeters, and then I would know that all my angles then would be 60 degrees. So equilateral and equiangular. Triangle DEF with measured angle D is 150, so it's obtuse. And then my 2 other sides are 1 inch. So here's my obtuse angle, D, 150, EF. They are both 1 inch, 1 inch. So then I have, let's see here, I have 2 congruent sides, meaning it is isosceles. And then I have an obtuse angle, so it is an obtuse triangle. Triangle GHI, where the measured angle G is 30, the measured angle H is 45. So I'm going to have a triangle that looks something like this. Put G here, 30 degrees, H here, 45. Well, let's figure out if this is going to be an acute or an obtuse angle. Well, I know that 45 plus 30 gives me 75. Take that away from 180 and I get 105. So then I know that I is an obtuse angle. And it also tells us GH is 4 centimeters. So I'm going to have an scalene triangle. All my sides are different, and then an obtuse angle, meaning it's an obtuse triangle. Triangle NOP, where we have a right angle at N, and then my other 2 sides are 2.5. Here's N, O, P, NO is 2.5, and P is 2.5. So I'm going to have an isosceles. 2 sides are the same. I spelled that wrong. I'm going to spell that wrong all year. And then I have a right angle, so it's a right triangle. Now last one here, triangle QRS, where the measured angle Q is 100, and then my 2 sides, one is 1 inch and the other one is 1.5. Here's angle QSR, so 100. QS is 1 inch, this is 1.5. So again, I have 3 different sides, so that is scalene. And then I have an obtuse angle, so therefore it's an obtuse triangle. I want you to do these 6 on your own. I'll check them and either give you a piece of candy or points or something for doing them. Thank you for doing your part in watching this video. I will talk to you our next class. Thanks.